Good morning. I'm Dr. S.B. Tirumlesh Nayak. Today's topic is supercritical fluids from Physical Pharmaceutics, B Pharmacy third semester. Learning objective of this topic is after this presentation, you can understand definition, properties of supercritical liquids, application in pharmacy and industry. Definition of supercritical liquids. Supercritical fluids can be defined as a substance that exists above its critical temperature and critical pressure. In this state, the substance does not have a separate liquid and gaseous phase, and it behaves with properties of both liquid and gases. Supercritical state will be existed only when the temperature is above critical temperature and the pressure is above critical pressure. Example for this is supercritical carbon dioxide. It is commonly used in pharmaceutical industries and several other pharmacies. You can see the phase diagram of the supercritical liquids. X-axis is temperature, y-axis represents the pressure. The blue line, the line, this line, the left side of this line, the color blue represents the solid phase. The color, the right side of this line up to this, it is a gaseous phase here. This line, the line here, this is a gaseous phase and this is the liquid phase. The point here you can see in an orange point, which is called a critical point. At critical point, the temperature is called critical temperature. At the critical point, the pressure is called critical pressure. Why we are calling it as a critical temperature and critical pressure? Because above this critical temperature and pressure, this liquid and gaseous phase, there will be no we cannot distinguish gases from liquids and liquids from gases. Both these phases will combinedly form and give as a supercritical fluid which has both gaseous properties as well as liquid properties. Properties of the supercritical fluids. Supercritical fluids show unique properties due to mixed liquid and gaseous behavior. You can see the diagram here. Supercritical fluids, a substance above critical temperature and critical pressure. So, with a high temperature, when you increase the temperature more than critical temperature, this fluid is having more dissolving power and it is having high density because the liquids as these liquids are in high temperature, they always try to maintain an equilibrium with the liquids, so they always having high density and they try to become as a droplet. And because of this high temperature in the liquid, the molecules which are in the liquid phase, they are gaining the kinetic energy from the high temperature, and due to that the viscosity of this liquid is decreasing and it is acting as a like a gas. And because of this low viscosity, the flowability of this liquid is high, and diffusivity of this supercritical fluids. So the diffusivity is very high and it is a property of a gas. So the penetration of this supercritical fluids is very high into the solids as it is having high diffusivity. And this diffusivity is due to the high temperature and the kinetic energy which these molecules are gaining. Because of the high pressure, which is pressure above the critical pressure, they will decrease the surface tension to zero, and which will be helpful for penetration of the this supercritical fluids into the smaller particles and spaces is very easy. And this deviation in temperature and pressure can be used for the tunable solubility of this supercritical fluids. And the solubility is the property of the liquid. Selective extraction. Because of this supercritical properties, this fluids has a selective extraction of several drugs. So, as I told you, this high diffusibility diffuses faster than liquids and penetrates solid materials easily and useful in drug extraction, cleaning, and chromatography. And we are having no surface tension. So, supercritical fluids have almost zero surface tension, can penetrate fine pores and small spaces better than liquids. Solvent power is adjustable. So, this supercritical fluid solvent power can be adjusted by changing the temperature, pressure, and co-solvency, which can be also called as tunable solvents. Because of their high compressibility, small pressure changes causes large changes in the density of this supercritical fluids, helps in controlling the solubility and suppression processes. Next one is selective extraction. These supercritical fluids can dissolve specific compounds selectively, especially useful in natural product extraction like oils, flavors, and drugs. Coming to the application of the supercritical fluids and industrial uses and benefits of the supercritical fluids. These supercritical fluids are used in the extraction of essential oils, herbal extracts, flavors, fragrance, and decoffeeification of coffee and tea. And second one is these supercritical fluids are also used in the chromatography for suppression and purification of the drugs because of this chiral separation of the molecules. Drug particle size reduction. As these particles are having very less viscosity, these particles can form a very fine very fine droplets, which are useful in the preparation of the micronized particles and nanoparticles, which will improve the solubility and bioavailability of the drugs. Next one is supercritical drying. Uh, if we use the volatile liquids for preparing the supercritical fluids, these volatile supercritical fluids, which can be used in the preparation of the aerosols and porous materials, useful especially for the heat sensitive drugs and heat sensitive products. Coming to the industrial uses and benefits of the supercritical fluids, impregnation or drug loading is very helpful with the help of these supercritical fluids. Drug incorporation into the polymers and implants and other devices is easy with the help of the supercritical fluids because of their high penetrability. And this supercritical fluids acts as a green solvent in chemical reactions, that is hydrogenation, oxidation, and polymerization. Supercritical fluids in the industries, they are also used in the sterilization and precision cleaning of the several medical devices, electronics, and etc. In the food and cosmetic industries, these supercritical fluids, they are also used in the extraction of the vitamin E and several lipids, and in some extraction of the perfumes. The major advantages of this fluids are they are non-toxic in nature, they can be recyclable, and they are eco-friendly in nature. No solvent residue can be seen in the cleaning or sterilization process, and in the formulation of the different dosage forms. There will be no solvent residue, and they are highly pure. And these supercritical fluids can be used for the tunable solvent power by adjusting the temperature and pressure. These are also very much useful as they are having very high diffusibility and high selectivity. References, these are the references I have referred for preparing this PowerPoint presentation. Thank you very much for listening. Goodbye.